Hey guys, welcome back. This is a one from an AP test a while back. Not super recent, but recent enough that I'm happy to do it. It was a calculator question, so you can use calculator to do the integrals. In this one, it says let R be the region bounded by the graphs of sine of pi x and x cubed minus 4x. You should know that this curve that starts at 0 and goes through 1 and goes to 2 is sine of pi x. Okay, we'll expect it. Again, since this is a calculator question, you could punch all this up in your calculator and graph them and see which is which. Y equals x cubed minus 4x. So we know which is which. Then it says the region R, which is this region, is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Find the volume. Remember, perpendicular means right angles to the x-axis. So the cross-sections go like this. Like all of these things have length s. And again, that changes as x changes, but s is a function of x, so that's okay. And to find s, we're going to do top minus bottom. So the top curve is sine of pi x. The bottom curve is this one, so minus x cubed plus 4x. Remember, you got to subtract both of these. So this is s. And a of x is s squared. So it's like this thing. I don't want to write again, but it's this whole thing squared. I got to square the whole thing. I'm going to write it again so you know what I'm talking about. Sine of pi x minus x cubed plus 4x squared. Like this is the area function. Top minus bottom, and square all that, the whole thing. So the volume is the integral of the area function from A to B. Where A and B are the limits of whatever the region is. In this case, it's pretty clear that the limits are 0 to 2 of sine of pi x minus x cubed plus 4x squared dx. This is the part you would do in your calculator. This would be a kind of a tricky integral to do without a calculator. We don't have to worry about that. So let me put this in my calculator. X cubed plus 4x squared dx. I get 9.978-ish. 9.978. So that's one that, again, like I said, they put on the AP test, so it's like a reasonable question, I think. Yeah, there's only 2 more examples, so I'll do those two and then we'll be done. There are 3 examples? 1, 2. Yeah, this one's pretty hard. Might save that one. We'll do these 2 for sure. By the bottom side is base of a triangle, so that's plus 1 y, blah, blah, blah. Okay. So we have ourselves a shape. Pretend for a moment this is an x and a y axis. And then our shape, the line x plus y equals 1 comes down like this at a 45-degree angle. And intersects all the ones. 0, 1, 1, 0. The area they're talking about is right here, this little region, because that's the x and the y axis, and this thing, and the cross sections perpendicular squares. So like, oh, it's just to the y axis. Now you got to write these things in terms of y. It's actually not that much more difficult. I think this would be the same if you did in terms of x, but we're going to do it in terms of y nonetheless. So just like before when we were doing the areas, when we did it in terms of x, we did top minus bottom. And things were like y equals something with x's. But when we do perpendicular to the y-axis, when we go horizontal like this, we got to do right minus left. Everything has to be in terms of y, like x equals something with y's in it. So for example, this is a line x plus y equals 1. I could also write it as x equals 1 minus y. Now, this line here is written as x as a function of y. And that's like the right side of this region is this red line, and the left side is the line x equals 0. That's the y-axis, x equals 0. which means my S's, which are these green lines, are really the left minus the right. So it's 1 minus y. Should call S of x is y's. S of y, right? This distance here is 1 minus y. Think with that for a minute, like, that's good. When y is 0, it should be 1, and it is. When y is 1, it should be 0, and it is. And it gets bigger between those two. That's kind of how that should work. We're doing square cross sections. My area function, a of y this time, is s squared, which is 1 minus y squared, which is 1 minus 2y plus y squared. Then my volume is the integral from a to b, a of y dy. The integral from, let's see, it starts at y is 0 and goes to y is 1. 1 minus 2y plus y squared dy. Like I said, I think if you did this in terms of x, you get this exact same integral because this thing is symmetric in every way, but it should do it. Since it says perpendicular y-axis, you should do it in terms of y. So y minus y squared plus y cubed over 3 from 1 to 0. 1 minus 1 plus a third. All right, 1 minus 1 plus a third minus 0, which is a third. Let's let you do that one in terms of, this one was in terms of y because the cross section perpendicular to the y-axis. So they went sideways now. Got to do, again, this is like right minus left this time instead of top minus bottom. Okay. Last one. Let R be the region enclosed by this graph, as shown in the figure above. It's not exactly above, but you get the picture. Region R is where each cross section is isosceles right triangle. Okay. So perpendicular to the x-axis, so we're back in the world of normality where we're going up and down. So my S's look like this. All my little sides and my shapes look like this. I'm having trouble drawing straight lines today. Nope, that's just worse. My S's look like that. They're in the region here like this. So to find S, I do top minus bottom. The top is 4. And the bottom is this thing, which must be this curve, so it's minus x to the 4th plus 2.3x cubed minus 4. If I subtract that whole thing, top minus bottom, which ends up being negative x to the 4th plus 2.3x cubed. And now I think a more salient question might be, what is the area function now? Because no longer is it squares. Each cross section perpendicular to the x-axis is isosceles right triangle with a leg in R. That means is that the things sticking out here now look like this. They're like triangles sticking out. And each one is isosceles where like this is S and this is S. And this long side is S root 2. I don't know if it matters, but it is. Either way, if I kind of sketch that triangle over here, it's like S and S. Well, the area is 1/2 base times height, so it's 1/2 S times S, just 1/2 S squared. So that actually doesn't surprise me that much. If it was a square with side S, it would look like that, and this is half of that. So area function is 1/2 times S squared. Negative x to the 4th plus 2.3x cubed squared. This one you could probably do without, you could probably square this thing without that much trouble and then do the integral yourself, but we only have to. You do have to figure out this, like I know that this, it looks like this point of intersection is pretty clearly 0. And let's see, when x is 0, this is 4 and y is always 4, so that's clearly a point of intersection. So like, I guess the question is, where do these two things intersect? And we know how to figure that out. You just set them equal to each other. X to the 4th minus 2.3x cubed equals, minus 4, plus 4, excuse me. Plus 4 equals 4. I subtract 4 from both sides and those go away. So I'm left with x to the 4th minus 2.3x cubed. 0. Factor x cubed out of all of it. So I get x cubed times x minus 2.3 equals 0. Which tells me that my two zeros are 0 and 2.3, which are the two. This means this point, this is 0. And this has got to be 2.3. That's the only other point of intersection of these two things. So my volume, again, is the integral from a to b of a of x dx, which in this case is this thing, 0 to 2.3. I'll put the, doesn't matter, the 1/2 goes 1/2. You could, yeah, I could have put it on the outside. And if I was actually going to do this integral myself, I probably would have. The fact is, I'm just going to put it in my calculator anyway, so it doesn't really matter. 2.5 times negative x to the 4th plus 2.3 x cubed squared dx. I get 3.573-ish. .573-ish. Yeah, 1/2 s squared. Or 3.574. This is truncated and this one's rounded. So I'm going to take a look at this one in class. It's actually not, this one's not that bad for the shapes, but like this height of y cubed thing is a little confusing. So that's about it for today. See you all in class. Bye.